Okay, let's look at simplifying some expressions with square roots in them. Simplified square roots are often called surds. So the first one I've got to do is the square root of 7 squared. That means we have to multiply it by itself. But the whole point of the square root of 7 is that it's the number when you do multiply it by itself gives you 7. So squaring a square root just takes you back to the number it's the square root of. Okay, and that helps us simplify these other two. So if I think about the square root of 3 being cubed, then I've got the square root of 3 times the square root of 3 times the square root of 3. Now if I just look at the first two of those, I've got a square root times itself, and the job of that, square root of 3 times itself, must equal 3. So this is going to equal 3 times the square root of 3. And then I've got the square root of 2 to the power of 9, which is just like the previous one, except I've got several pairs of the square root of 2. So it's the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2 dot 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 times the square root of 2 at the end. I'm not going to write them all out, but I can see that each pair, where I can pair them up, of the square root of 2 times itself is going to equal 2. So that's going to equal 2, that's going to equal 2. Still being multiplied together. How many whole 2's am I going to be able to make? Well, in 9 I can have 4 pairs of the square root of 2 times itself, but then I'll have 1 square root of 2 left over at the end. So I'll have 2 times 2 times 2 times 2 is 2 to the power of 4, which is 16. Okay, and then I'll have the square root of 2 to put in at the end. We'll quickly look at one more, which is the square root of 5 to the power of 6. So that's square root of 5 times the square root of 5 times the square root of 5. Okay, so each pair of the square root of 5 times itself, its job is to equal 5. And in a power of 6 overall, okay, I'm going to be able to make 3 pairs, and therefore I'll have 3 copies of 5, 5 times 5 times 5, 5 cubed, which is 125. So it turns out when I've got an even power of a square root, like 6 or 2, I'm going to get a whole number answer, okay, because I'll have a whole number of pairs of the square root times itself. Whereas if I've got an odd power of a square root, then I'll have the original square root appearing in the answer, but then I'll have a whole number in front of it formed by the ones that do pair up. So I hope that helps.